I mean, I'm just connecting a rope to a shaft. How many things could I mess up? Quite a few, actually. This solar tracker moves the panel using winches, so if the rope to shaft connection slips, the whole thing fails. In this video, I'll cover the mistakes that set me back, 2 tips for moving forward, a problem I still haven't solved, then I managed to destroy everything, and finally, if you stick around to the end, I'll share some exciting news on what's coming up next. Starting with the first mistake. To connect the rope to the shaft, I figured all I needed to do was add the shaft collar and tighten the set screws. Then tie the rope around the long set screw to hold it in place. Bad idea. With about 100 pounds pulling on it, I started it up. Notice how the set screws stay still and these spool ends keep moving? That's not good. It's clearly slipping, a lot. I tried scratching up the shaft for more grip, but I still wasn't confident it was right, and this can't be something that fails. Turns out I had these more common concave end set screws when I should have gotten these cone point set screws instead. The concave end ones just don't grip like the cone point ones do, and cone points hold even better if you make a little dimple in the shaft. But you have to space these dimples correctly, and making them in the right place isn't trivial. In the past, I've used 3D printed jigs for something like this to hold the drill in place. Here's one that I made a while back to put the set screw through an older worm gear I was using. But it takes time to design and print, and the final jig is made of plastic which won't hold forever. But a friend gave me this really great tip. Let the shaft collar be your guide. It already has the holes exactly where you need them. You just need to get a hollow lock set screw that has a hole in it. Then just drill right through this fancy set screw to mark your dimple. No jig design or 3D printing, just use the part itself to line up the hole. But an issue is now that I have to buy a pack of 25 when I only need one ever and wait a week for it to show up. Rather than just wait around and firmly believing that patience is for the lazy, I thought maybe just make one. And instant hollow lock set screw without having to stop and wait a week for the part. Hey, quick time out here. There's a lesson here beyond just securing a rope to a shaft. Our minds, or at least my mind, is always trying to find some way to quit. Like, I can't do this now, or I need this or that. And so you stop and you go to the store, or you wait for a part to arrive. But those hours, days, and even weeks really add up. And so the lesson here is, if you want to make progress on the big things, you really have to be hard to stop on the small ones. All right, back to it. So now the set screw is solidly in place for the rope to grab onto, but these rough edges on the set screw are going to keep chewing away the rope over time. My original solution was to cover it with this super thick duct tape, but I was informed that things like tape and glue just don't last, especially in the heat. What do we use instead? Well, they make these rubber caps that cover screws just for this purpose. So that's it. Simple, cheap, way stronger than tape, and will survive the heat. Thank you to Kyle for that heads up. Finally, Stephen pointed out that the rope tie I'd been using to keep the rope from coming over the set screw just wasn't ever going to hold, and he's right. I have these zip ties holding up the string lights in my backyard, and they break all the time. There's one out there right now that I have to fix. There's no way that'll last. But maybe here the best part is no part. For now, I'll just skip it and make sure I go around it twice with the rope before putting weight on it. There it is, a cone tip set screw with a dimple to lock onto, a cap over the set screw, and no more flimsy zip tie. Before I show everything working, I just wanted to share one last problem I haven't quite figured out yet. This worm gear doesn't have a set screw to dig into the shaft, and so I'm not quite sure how to keep it from slipping. Scoring the shaft helps a lot, but I feel like there's more that I can do. If I had some kind of shaft collar that had a notch in it that could dig into this gap, that might be a way to do it, but honestly, I'm really not sure. What about you? Have you run into this or any other similar issues? Any tips for me here? And also, if there's any builder content creators out there, I'd love to see how you're tackling your own projects and even how you're making your videos, because it's kind of a different thing. So please leave your channel in the comments. I'd love to check it out. There's no reason for us to go at this alone. Might as well help each other out. Here's the part where I destroy everything. I set up the new winch with the dimpled shaft collar. It has a rubber stopper on it, and I just want to see that weight lift without the rope slipping. Those of you really paying attention will have noticed that I have the rope hanging off the other side. The direction doesn't matter here for a demo, so I'll just flip it around. Okay, now lifting up. Then it happened. The not happy sound. At first, I thought I didn't center the worm gear on the worm. I don't usually make that mistake, but if it's not centered, it'll hit that ungrooved smooth part and grind against it. So I moved this part forward to center it, tried again, and no, same sound. But I know it was centered. That's what I just stopped to do. Then I noticed that now not only was the worm gear uncentered again, but the whole T-slot rail had pulled back. You can even see it slide back here. That's what was causing the worm gear to be in the wrong place. Not that I was setting it up that way, but after it started, it pushed the railing back and that moved the gear back. I've done these kind of tests before and this hasn't been a problem. I think the issue here was though that I screwed it in over my head, so I wasn't really getting my elbow into it to tighten it. But anyway, this completely wrecked the brass gear. The stainless steel worm seemed okay, but the brass part was shredded. I cleaned off the mangled brass bits from the steel worm and then replaced the gear with the one that I had on the other axis. In addition to tightening it more, I added another T-nut on the railing to keep it from sliding back. And now let's see what happens. I don't hear the grinding and breaking of gears, so that's good. The gear is staying nice and centered. But yeah, this is still slipping. An issue here is the cone point isn't going in deeply enough. As an aside, you really don't want to drill something like this in your hand or the bit could break and cause an injury that looks remarkably similar to this. Drilling into this 304 stainless steel is really a beast. I had trouble getting the drill to go deep, even trying multiple bits. Finally, I tried using a Dremel to go deeper. That cut really well. Maybe a diamond tip Dremel bit would be the best choice in the future. Got the tip of the cone in there. Let's put it all together and try it out. And that's lifting. Success. No slipping here, so that looks good. Now onto what's next. I heard that adding a solar panel to a solar tracker dramatically increases its power output, so I thought I'd give that a try. Seriously though, I just got the panel and the framing for it, so it's time to put the whole build together. Definitely nothing could go wrong with that. Anyways, I'm really excited about it, and you can see what happens right here. If it's not ready yet, just click subscribe and hit the notification bell so that you don't miss it when it comes out. And if you want to see how I got to this point, then you can click this link over here. All right, thanks for watching. I'll see you in the next one.